All right, so we went through the basic properties of logs, right? That I called rules, I guess. I guess I called them the product rule, the quotient rule, and the power rule, which are really bad names, honestly. If you get into calculus or if you've taken calculus before, you'll know why those are bad names because you have the same rules in calculus for derivatives. So I think usually most books would call these the product property, the quotient property, and the power property of logs rather than rules. But what are you going to do? It's already out there. All right. So all you see at the top of this page here is it says, of course, in many problems we need to combine these rules. So by these rules, I'm talking about the log properties, right? Which I'll call properties now, even though, like I said, it's all the way out there, right? So we're combining log properties now, right? The product property, the quotient property, and the power property. So in other words, you get something like this. Log maybe of AB over 10C, right? So what do you have here? You have a product in a numerator and a product in a denominator. So really, it's like a product, and a quotient. Okay? So you might say, all right, well, I'll do this thing in like, I guess, 3 steps or so. I'll do the quotient rule first, then I'll do the product rule in the numerator, then I'll do the product rule in the denominator. I wouldn't recommend that though. What I would recommend doing is what I refer to as my generalized rule, which is basically going to state that any factor in the numerator will become positive and any factor in the denominator will become negative. And that should actually make sense from when you would do exponent rules, right? If you had an exponent in the denominator, it was really a negative exponent, right? And in the numerator, it was actually a positive exponent. So that generalized rule there, that if it's in the numerator it becomes positive, if it's in the denominator it becomes negative, actually makes sense if you think about exponents in denominators, okay? Because that's what logs are, right? Logs are exponents. So what I'm going to do is I'm just going to use my generalized rule, and I'm going to say, all right, well, what do I have here? I have 1, 2, 3, 4 factors, right? A and B are in the numerator, and 10 and C are in the denominator. So the log of A and the log of B are going to be positive, and the log of 10 and the log of C are going to be negative. So when I write this, I'm just going to write it immediately as 4 separate logs. So it's log of A plus log of B, because they were both in the numerator, minus log of 10 minus log of C, right? So the ones that were in the numerator became positive. The ones that were in the denominator, namely the 10 and the C, became negative. And then, of course, as before, in my last video, I can sometimes simplify, right? Log of 10 is actually 1. So this is really log of A plus log of B minus 1 minus log of C. And that would be your expanded expression, right? So in this case, I was given a single log and I expanded it into multiple logs, okay? So you can also have the reverse scenario where you'd be given something like, use ln this time, right? ln of x plus 3 ln of y minus 1/2 ln of z, right? And what they would ask you to do here is, you're not expanding now because this is already 3 logs. they would ask you to combine into a single log. So what you're going to do here is you're going to use, actually in this case, you're going to use all three properties. You're going to use your product, quotient, and power. So the first thing you really want to do is recognize, hey, I have a 3 and a 1/2 out front here in front of those two logs. So where would those have come from? Those actually would have come from the power rule. They would have been powers of y and z in this case, right? 3 would have been the power of y, a half would have been the power of z. So the first thing I'm going to do is put them back in their power position. So write them as ln of x plus ln of y to the third minus the ln of z to the half. And you could write that as the ln of the square root of z, because the half power is the square root. Remember from unit 3, I guess. So that's the first thing I do. I put all those coefficients back in their power position. And now I can use my generalized rule from above that said any positive log is going to be numerator, any negative log is going to be the denominator. So I can immediately just write, all right, I know this is going to be a single log of something, and it's going to be a fraction, right? It's going to be some quotient where any positive log will be in the numerator. So which ones are positive? The x and the y cubed. So I put the x up here, and I put the y cubed up here, and any one that's negative, namely the z to the 1/2, is going to be in the denominator. So I have the ln of xy cubed over z to the half. And now the mistake that some people will make in this case is they'll do this. They'll put a plus there. Incorrect, right? These things are always factors. So in other words, they're being just multiplied and divided, right? There's no addition or subtraction signs in here, unless there's an addition or subtraction sign in the initial, in one of the initial expressions. But in general, you're not, inserting any addition or subtraction here. It's just all multiplication, division. Okay? So that would be an example of using all three to combine into a single log. All right? So that's what I say here about the combining and expanding. You got to remember to read the problem carefully to determine what you're expected to do in any given problem, right? If it says write as a single log, what you're doing is what we just did there. You're combining. And if it says write as the sum or difference of logs, right, you need to break it up or expand. So you're either expanding into multiple logs or combining into a single log, right? Those are the two choices. Okay. Now, just one other thing that you could possibly see is, let's say I have something like log base 4 of 8 plus log base 4 of, I don't know, 6 minus log base 4 of 3. Right? This, you can look at all three of these logs and say, all right, well, none of them are exact, right? So the only thing I would be able to do here is use my change of base formula and get like an approximation for them. The problem is those are just approximations, and you don't want just approximations. You want a precise value if you can. So what you would do here is you would actually use your properties, right, and expand, I'm sorry, not expand, you combine this into a single log, again realizing, hey, this is going to be the log of some quotient where any positive one is going to be in the numerator, any negative one is going to be in the denominator. So in this case, I have an 8 and a 6 that are both positive, so those are going to be in the numerator. And again, remember what we said last time, they're not added, they're multiplied because these are all factors. And then that log base 4 of 3 was negative, So the 3 will go in the denominator. So I have log base 4 of 8 times 6 over 3, but now look what happens here. This is really log base 4. 8 times 6 is 48, and 48 divided by 3 is actually 16. And now this is actually just an exact value, right? The log base 4 of 16 is just 2, because 4 squared is 16. So this is an example of you expanded, I'm sorry, I keep reversing the words. You combine those 3 logs into a single log. Neither one of those 3 logs, right? None of those 3 logs were exact the way they were. But when I combined them into a single log, it actually gave me an exact value, which was very nice. So when you have your test 4, look out for one like that possibly, where you combine, and then after you've combined, you can actually simplify the log down to just, a natural number, which in this case is 2. Okay, so that's pretty much it for 9.4. It's really just those 3 log properties: product property, quotient property, and power property, along with the change of base formula. So that's pretty much it.